Hey kids, welcome to another amazing lesson. Again, I hope these are helpful. If they are, click subscribe and you'll be notified when I upload a new lesson. This is lesson 8 in module 4, and this is really a huge concept today, so I'm gonna for sure end up having 30 minutes. Parents, pay attention. This is the one where they're finally going to connect cross-canceling and why this works. So really important lesson. Coming hot on the heels of lesson 7, which is also a really huge lesson. So we're still doing fraction of a number, which was from the previous lesson 6. Really easy. Look at your sets. You've got little diamonds. You've got fun figures. You're just taking a fraction of a set. But we can't make fraction models all the time. So we need to find a way to put this into a math numeric expression so that we can work with it. So let's take a problem like 2/3 times 6 or 2/3 of 6. So in multiplying with fractions, all the parents know, but we get to multiply the numerators and multiply the denominators. So really in these fractions, the 6 or any whole number is going to be over 1. So once I do this quick little thing in my head, I can rewrite so that all my factors on top are separated, and then I just have this single denominator. If I go ahead and multiply, I see that I get 12/3, which you know this is a division problem, so 12/3 is equal to 4. So what does it mean when I shift it around? And what if I did like 2/3 6 times, which is what today is all about, showing you 2 different methods to get the answer. Well, really 2/3 6 times, 1, 2, 3, 4, 5, 6 would give you all the 2's you need. Also, they're going to use the word copies. So 2 copies of 6 would be 6 plus 6, but 6 copies of 2 would be all these 2's. And so they're going to show you 2 different ways to create these models. First of all, taking the whole, which is 6, and finding 2/3 of it. Now this may be really familiar for all the kids because we've been working with it this way. Take the whole, divide it into 3 parts. What would be the value of 2 of those? That was using the 6 equals 3 units. I want to know what 2 units are, and so then you do that division, multiply by 2, so you can finally figure out what the parts are. But other kids may see, well, I know that 2/3 and multiplication, this is going to be repeated addition. So 2/3 6 times looks like this. Now if you do the repeated addition, you get the answer on top. And if you do the whole, you get the answer on the bottom. Big difference in these models, okay? So that's part of what makes today really special. Now there is another problem here, the 3/5 of 10. So this is again from the teacher's manual, and it's just taking a fraction of a whole. Here's what the whole would look like. Here's what the fractional units would look like. We need 3 of them, okay? If you do the multiplication, 3 times 10, this is where it starts to introduce the cross-canceling. When you have the 3 times 10, and it was 10 over 1, which 1 times 5 is 5, you can shift. It's this denominator that is kind of floating back and forth because of the commutative property. I can move my denominator, and remember, it only works with multiplication and addition. So I can move my denominator. I can change the 3/5 and move the 5 over to here and call this 10/5. Now, if I do this, 10/5 is equal to 2. 2 times 3 is 6. So that's another way of showing the answer. Here's the 6. And then when I multiply 3 times 2, I get 6. So this one's already been kind of worked through. It's a little harder to follow. Okay. This is the cross-canceling already done. That might be confusing, so I have one more sample before I show you a homework question. Okay, so 3/5 of 10, here, if 3/5 of 10 equals 6, as shown in this tape diagram, okay, then this is where that shuffling takes place, okay? If 3/5 of 10 is equal to 3 times 10 over 5, Then move the 5 over to here, and you really get 3 times 2 for 6. Here is the cross-canceling. Same problem, but just cross-canceling. Okay, this is the 10/5, which is equal to 2. And so it's just kind of the way that, that you guys can break it up. The whole is going to be put into this fraction, and then you can start thinking about how to break up the whole and what would be, sorry, not this one, what would be a good factor of that number to use. So with 24/6, again, you should really know your times tables. If you use 24/6, 6 is a factor of 24, and you can simply divide both by 6. 6 divided by 6 is 1, and 24 divided by 6 is 4, or 24 divided by 6 is 4, and just leave it at that, and 7 times 4 is 28. Okay? Now, if you use a harder number, let's say 7/6 of 27, if 27 is not divisible by 6, you have to start thinking about what makes up 27 and what makes up 6. That's what this is here. So if 27 is a product of, say, 9 times 3, and 6 is a product of 2 times 3, then what you can do is you can use the common factor, divide both numbers by the common factor, and so use 3. 6 divided by 3 is 2. 27 divided by 3 is 9. Now I have simpler numbers to multiply, and I can get my final answer, 63. Instead of ending up 7 times 27 is 189/6, then having to divide by 3 to simplify, you can get 63/2 on your first go round from using the simplified factors. Finally, I know this is all probably a lot. When you get into the problems, it'll actually make more sense. On the homework, this is another example of how to split it out. If I have 18 times 5, I don't really want to have to do 18 times 5, so you can set it up by splitting the 18 into 6 times 3 and splitting the 12 into a 6 times 2 right here. If you can do that, you can use the 3 as your common factor, and so you pull that out. It's supposed to help you. It's supposed to help you reduce the size of your factors before you actually multiply them. So, with that all said, then we're going to start lesson 8 in the book. Okay, I didn't have my book ready. Here we go. We are starting now. So, Laura and Sean find the product of 2/3 times 4 using different methods. These are going to be the 2 different methods. So 2/3 times 4 would be 4/3 plus 4/3. So we're going to use the 4 2 times. 2 times 4/3 is 8/3. This is what Laura says. Sean says, well, I know it's 4 groups of 2/3. This is what we've been doing all along to check our other work, and it's 4 times 2/3, and they both get 8/3. So how can you use pictures, words, numbers to compare their methods in the space below? So let's take a look. So if I have 4 and I need 2/3 of that, this is what I'm trying to do. Then you can use all those the units. Okay, so it would be the 4/3 and 4/3, so that equals 4 divided by 3, and then I have 4/3, and that equals 8/3. Okay, and then what if I want to show it this way, and I have 2/3 plus 2/3 plus 2/3 plus 2/3. Oops. Okay, then I have 8/3, which is equal to 2 and 2/3. So it's either going to be the whole on the top or the answer that you're getting. Oops, not there, but here. Not the word below, but here, the answer 2 and 2/3. Okay, now this is because of all these different properties that we can kind of shuffle things around. So let's do another sample problem. Rewrite the following addition expressions as fractions, as shown in the example. So if this is 3, 1, 2, 3 times, then we're going to use the 3 times 7/4. Whoops. I am having some struggles here today, keeping things together. So 3 times 7/4 would be 21/4. And so we're just going to show the addition expressions as fractions, as it's shown up above. So here's the multiplication expression created from our repeated addition. Okay, and then we just have our final answer. And you can leave it improper today. There's really nothing special about it. We're just going to leave it. How many times do I have 14/5? And then put that in one statement or one expression over the denominator 5, and then just go ahead and multiply for 28/5. Just leave it for now. I know it drives me nuts to see improper fractions, but you can just leave it for now. How many times do we have this? We have it 3 times. So write your expression, and then write your fraction example answer. Okay? Let's start creating these models. This is where it gets a little bit tricky. Okay. So if I have this as my whole and I take 2/3 of 6, okay, then my answer is here. So this is where we're going to split the whole. This one is we're going to create the answer. And that's the difference between these two models. Okay, notice that the whole here is 6 and we're splitting it and getting the answer. 2/3 of 6 is 4. This one is repeated addition. So we're doing 2/3 6 times. 1, 2, 3, 4, 5, 6. Add them all up. You can add them, or now we're turning that addition into multiplication. That's just what you did here. You're taking the repeated addition and turning it into multiplication. Now, the reason we're doing that is so that we can learn how to cross cancel or simplify before we multiply. Okay, so that's all done. And I don't think there's anything special I want to show you guys. So how about 1/2 times 8 is half of 8. So let's do 8 is the whole, and I want half of it. Create your little fraction tape diagram. Okay, and we want half of 8. So it's going to be basically 1 times 8 over 2. And you can do a couple different things here. You can do 1 times 8 is 8 over 2, or you can do 8 divided by 2 is 4. And so either way, you get 4 for your answer. So you're creating the fractional part of it. For this one, notice it's the same problem. They just flip the order of the factors. And for this one, we're going to do repeated addition. So make 8 boxes. Split it in half, that's 4. Split it, and then split them all again. And then it's 1/2. All those times. Okay, and so we're creating the answer up here. Okay, so again, numerically, 8 times 1/2 is going to be 8 times 1 over 2, which is really 8/2, which is equal to 4. Okay, so this is equal to 4. So here we're splitting the whole, here we're creating the fractional answer. How about the next one? 3/5 of 10. 3/5 of 10. 10 is the whole. 1, 2, 3, 4, 5. I want 3 of the parts. Okay, so we're going to do 3/5 of 10, which is really 3 times 10/5. So this is where we kind of get to do that commutative property. Move the 5 over so that this becomes 2, and then multiply 3 times 2 instead of using 10/5. Okay? So that these 3 sections would be equal to 6. You can also make it 2 if you end up finding the piece of 1, but now you also remember, don't forget that step. If we're finding 3/5, you need 3 of them. The next section is 3/5 10 times. Make it a little bit longer. Split it in half. 1, 2, 3, 4, 5, and put 5 on each side. And then this is going to be 3/5 and etc. It's like 3/5, 3/5, 10 times. Okay, so it's going to be 10 times 3/5, or 10 times 3 over 5, or 30/5, which equals 6. And that's the top is going to be 6. Okay, so I know it's a pretty long lesson today. So turn the page because we have a little bit more drawing to do on the back. Now this one is where we're actually going to do the cross canceling. So the previous problems were kind of like a get ready for it, but here is where we actually start doing it. Now look again, same problems, 14 times 3/7, 14 times 3/7. So what are we going to do here? On the left side, you're going to set it up by taking the whole number and putting it into an expression. Then you're going to factor, which is all a fancy word for split. You're going to factor any number that can be split so that it is in a simpler form, just like we did here. This is factoring. We're taking these apart and saying what numbers make up this product. So 18 is made up from maybe 9 and 2, but it's also made up from 6 and 3. So you want to use the better number for the current situation, and it's going to change in each problem. So we just have to kind of see what happens. So you take the 6 and you split it into 3 times 2. So you may have 3 factors, but that's okay. We want everything to be as simple as possible. Get into the lowest terms that you can, okay? And then we take these 2 and work with them, and that leaves us with a really easy multiplication, or like the 3 divided by 3 is really 1, so 1 times 4 is 4. So we're splitting it out, you'll see. And then when we get over here, we're going to actually just do the straight cross-canceling using 3 as a factor, but say 3 divided by 3 is 1, 6 divided by 3 is 2, or 6/3 is equal to 2. Okay, as long as you understand that. I know this is kind of a lot in this lesson, so we'll just try our best. Just start by copying what I'm doing. So for the first one, we're going to do 14 times 3, just like we did here, and put that over 7. Remember, 7 is our denominator because it would be 7 times 1, which is 7. Then we're going to split apart anything that you can. 14 can be split, and you want to look for factors that include this denominator. 7 times 2 makes up 14, but don't forget the 3, because that is also still a factor. over 7. Okay. Now, once I have this laid out like this, I can see 7 over 7 times 6. And then this is equal to 1. And so we end up with 6. So this is how we do it on this one. And then this is the same problem, but instead of breaking it all out so that we know what we're working with, we're just going to do it. 14 times 3 over 7. I'm going to use 7 as my divisor. I'm going to cancel this one out and put a 2 up here. It's really dividing both numbers by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. That gives me 6 over 1, which is really 6. If you don't get the same answer for the left side and the right side, something went wrong. Okay, let's hustle. 3 times 36 over 4. Then break up this large number into something that will work. Now, I could use 6 times 6, but that wouldn't be very nice to use the 4. So use 9 times 4. Yes, now you really need to know your factors. Okay, now I can move it all around, but what I want to do is just recognize that 4 over 4 is going to become 1, and 3 times 9 is 27. Do it over here, over 4. And instead of actually splitting it out, just do the division. 4 divided by 4 is 1. 36 divided by 4 is 9. That leaves you with 3 times 9, which is 27. So we get 27. If you have different answers, you did something wrong. 30 times 13 over 10. And then I really want to break this up, and I want to find a factor that is within that. And 10 is a factor, so I would do 3 times 10. You can do 10 times 3. It doesn't matter. And then this would cancel itself out. 10 tenths is 1, and then that leaves you with 3 times 13, which is 39. And then over here, 30 times 13 over 10. You don't have to bother splitting it out because this is our scaffold. This is our step. Divide by 10, divide by 10, and we get 39. Now, think about this. When you have 13 tenths, that's an improper fraction. It's more than 1. If you're taking a fraction of a number, okay, think about the logic of the size of the answer you're getting. If I'm taking 3/4 of 36, I should get less than 36 as my answer. If I'm taking 13 tenths of 30, that's actually more than 30. So 39 as my answer makes sense. So same thing here, 9/8 of 32. I should end up with more than 32 as my answer because 9/8 is 1 and 1/8. Okay, so 9 times 32 over 8 equals, let's break up the 32 so I can get an 8 out of that. 9 times 4 times 8. 4 times 8 is 32 over 8. Now these cancel each other out, and 9 times 4 is what we're left with. And so 36 is more than 32, so that's a logical answer. Same thing here, 9 times 32 over 8. Use the 8 now. 8 divided by 8 is 1. 32 divided by 8 is 4. 9 times 4 is 36. How are we doing on time? Okay, all right, gotta hustle, we're almost done. Solve each problem any way you choose. Now, the last part of this lesson that I didn't do in the teacher introduction was about like time and using a clock or converting things. So it's the any way you choose. You can do the repeated addition. You can do a fraction of a number. I don't know. You do it the way you want. I'm going to do it this way. For this one, I'll say 60 is the whole, and I want half of it. So 60 divided by 2 equals 30. And so this is going to be the minutes. And so, oops, sorry. If I would just read the problem. 1/2 minute equals 30 seconds. Okay. And then 3/4 of a 60 is, again, if you find 1, if you use 60 as your whole, then we're looking for 3/4 of it. So you can do 60 divided by 4. Okay. And that's going to be this way. And then when you get your single unit, that would be 15, but you have to do 15 times 3. So this is what we've been doing up to this point, but you don't have to do it this way. You could do the cross canceling. Okay, so 3 times 60 over 4. And then you can do the how many times does 4 fit into 60? Okay, so 1 and then 2 are left over, so there it is, and then 3 times 15 would be the 45. So you can do it either way. A 3/4 of an hour is 45 minutes. Then 3/10 of 1,000. If you do your, let's just do it like we were going to do it up here. Just put it over in a fraction. 3 times 1,000 over 10. Notice that the zeros would offset, and we're left with 3 times 100, and that equals 300. And that's from Unit 1, Lesson 1. Multiplying, not for the fraction, but right here, like 1,000 divided by 10. And finally, 4/5 of 100. 4 times 100 over 5. And you can't divide 4 by 5, but you can divide 100 by 5 and get 20. And then when you do it this way, you're getting the answer right away, so you don't have to do that second step like I was showing you up here. Okay, so it's kind of nice to do it this way and to kind of move on. So anyway, that is just about it. That's it for today. So I know it's confusing. There's a lot to it. But once you get going with these steps, I am really hoping that it'll make sense. We will probably continue using this cross-canceling method pretty much in everything we do, because I will be looking and showing you, hey, look, we can simplify before we multiply. Anyway, I hope it was helpful. You guys have a super day, and I will see you on the next one.